Hi everyone, welcome back to the channel. So in our earlier video of acids, bases and salts, we have learned about different properties of acids and bases. We have learned about different indicators, organic indicators that were telling us about characteristic of any solution, whether the solution is acidic or the solution is basic. So in this video, we'll learn about different indicators, okay, that will be inorganic indicators. They will also tell us whether the solution is acidic or the solution is basic. We'll learn about neutralization reaction, application of those reaction in our day-to-day life. We'll learn about pH scale as well. So let's start the video. So we will learn about inorganic indicators in this video. So earlier we have learned about organic indicators like litmus, turmeric, China rose. Now we will learn about inorganic indicators like methyl orange and phenolphthalein. Phenolphthalein, methyl orange. So let's talk about phenolphthalein as an indicator first. Okay, if we add phenolphthalein in an acidic solution, the solution becomes colorless. Okay, while if we add this phenolphthalein in a basic solution, the solution becomes pink. So on adding phenolphthalein in an acidic solution, the solution is becoming colorless. While on adding this phenolphthalein in a basic solution, the solution is becoming pink. Okay. Now let's talk about methyl orange as an indicator. When we add methyl orange in an acidic solution, the solution becomes red. Okay. And if we add methyl orange in a basic solution, the solution becomes yellow. Okay. So this methyl orange in acidic solution will become red, while in basic solution it will become yellow. So these indicators tell us about whether the solution is acidic or whether the solution is basic. Okay. So now let's start neutralization reaction. So in neutralization reaction, what we see that both acid and base, they both neutralize the effect of each other. Okay, they both neutralize the effect of each other. Okay, so how? If we add acid and base, okay, if we are adding acid and base in a suitable quantity, we get salt. We get salt and water. Okay, so both acid and base, they both neutralize the effect of each other. Okay, so in neutralization reaction, on mixing acid and base, we get salt and water, and heat is also produced. Heat is also produced. Okay, so they both are neutralizing the effect of each other. Okay. So in this neutralization reaction, the acidic nature of the acid is destroyed and basic nature of this base is destroyed. Okay. Acidic nature of acid is destroyed and basic nature of the base is destroyed. Okay. And heat is produced. Okay. This heat produced raises the temperature of reaction mixture. Okay. So, like if we take example, if we take HCl, hydrochloric acid, and NaOH, sodium hydroxide, what we see that NaCl is being produced with water, and we see that heat is also produced. And this heat produced is adding the temperature of, increasing the temperature of reaction mixture. Okay. Now we will study about application of this neutralization reaction in our day-to-day life. Okay, so let's start that. So first application is indigestion. Now our stomach produces hydrochloric acid, okay, for digestion. But what if our stomach produces hydrochloric acid in large quantity? Okay, what will happen? We will get acidity in our stomach. We'll get acidity in our stomach if our stomach will produce hydrochloric acid in large quantity. Okay, so to get rid of that acidity, what we take? We take an antacid. Okay. This antacid is milk of magnesia. Or MgOH2. So what we are doing? We are taking a base to neutralize the effect of excessive acid, that is hydrochloric acid, in our stomach. Okay, so to get rid of this acidity, we are taking an antacid, which is a base, so that the effect of excessive acid that is being produced by our stomach is reduced. Okay, so first one is indigestion. Next one is sting. Now the sting of an ant produces formic acid. What does it produce? It produces formic acid. The sting of an ant produces formic acid, which causes irritation on our skin. Okay, so we apply a calamine solution. This calamine solution contains zinc carbonate, right? It contains zinc carbonate, which is a base. Okay, this calamine solution contains zinc carbonate, which is a base. Or we apply moist baking soda, that is sodium hydrogen carbonate. The sting of an ant was producing formic acid, and what we are doing in return, we are applying a base. What base? Moist baking soda or zinc carbonate. Okay. Now treatment of soil. So if any soil becomes too acidic, okay, then the soil becomes unproductive. Its productivity reduces. So what we will do? We will add quicklime or slaked lime to our soil. This quicklime and slaked lime both are base. They both will treat the acidic soil. Quicklime is calcium oxide and slaked lime is calcium hydroxide. So for treatment of acidic solution, we are adding base to the soil in form of quicklime and slaked lime. Okay, so these were some applications of neutralization reaction. Okay, now we will study about pH scale. This pH scale tells us about strength of an acid and base. Okay, so this scale tells us about strength of an acidic and basic solution. Okay, it measures concentration of hydrogen ion. It measures concentration or power of hydrogen ion. Okay, it tells us about how strong the acid is or how strong the base is, how weak the acid is or how weak the base is. Okay, so this scale has number from 0 to 14. This scale has number from 0 to 14. So any solution which has pH of less than 7, we can say then that the solution is acidic. And if the solution has pH of more than 7 and that pH lies between 7 to 14, then we will say that the solution is basic. So if any solution has pH less than 7, we will say that the solution is acidic. And if the solution has pH from 7 to 14, then we will say that the solution is basic. Okay. And if any solution has pH from 12 to 14, the pH of solution is lying between 12 to 14, then we will say that the solution is strong base. Strong base. Like sodium hydroxide, potassium hydroxide. Both of them are strong base. And if any solution which has pH like 10, 11, 8, 9, okay, less than 12, then we will say that the solution is weak base. Okay, the solution is weak base, like copper hydroxide, zinc hydroxide. Both of them are weak base. Okay, and if any solution has pH of 7, we will say that the solution is neutral. The solution is neutral, like distilled water. It has a pH of 7. And if any solution has pH from 0 to 3, it is a strong acid. It is a strong acid, like hydrochloric acid, sulfuric acid, HCl, H2SO4. Both of them are strong acids. Okay, and if any solution has pH like 4, 5, 6, okay, then that solution is weak acid, like lactic acid, formic acid, oxalic acid. Okay, so this was all about pH. So this pH scale is telling us about the strength of any solution, whether the solution is, how strong the solution is acidic and how strong the solution is basic. About the strength, it is telling us about the strength of any solution, whether the solution is, how much strong the solution is acidic or how much strong the solution is basic. It is measuring the concentration of hydrogen ion. Okay, so this was all about acid, bases and salts. If you are having any problem, let me know in the comment section so that I can address those doubts in my next video. Thank you for listening.